Hello! Yes, and welcome to our Objective 1.8 notes. If you watched the 1.7 notes, you know that those were pretty long. I am happy to follow this up. Happy to follow those up with this set of notes, which are only one page. So hopefully it don't take nearly as long. So Objective 1.8 says I can find the zeros of a function. The zeros of a function are where the function crosses the x-axis. You might also think of them as x-intercepts. When we want to find the zeros, we're wanting to find where those x-intercepts would occur. And to find the zeros, all we have to do is set f of x equal to 0 and solve for their variable. So let's try some examples. Find the zeros. Be sure your answer is fully simplified, and when appropriate, check for extraneous solutions. So what does that mean, check for extraneous solutions? Well, really there are two equations that we always need to check for extraneous solutions. They are if we have a square root or a radical, and that's because that number under the radical, whatever that value is, the radicand as it's called, it has to be positive. So that's something we'll have to check for. When we find a value for x, when we plug it back in, do we get a positive number under the radical? The other one is when we have a fraction. If we have a fraction that we're working to solve, and that's because, of course, the denominator cannot equal 0. Denominator cannot equal 0. And we're not allowed to divide by 0. So if we have a fraction that we're working to solve, a rational expression that we're working to solve, we need to check. So the two things we have to check for are square roots and fractions. So with that being said, that's when we need to check for extraneous solutions. Let's try to find our solutions from these examples. Let's look at letter A here, 5x minus 13. To find the 0, all I have to do is set f of x equal to 0. And then solve 5x minus 13. So how would I solve this? Add 13, so 13 would equal 5x. Divide by 5 on both sides, and we find that x equals 13/5. Boom, done. That's it. That's all it is. All right, no need to check for extraneous solutions there. However, on letter B, we will need to check for extraneous solutions because we're dealing with that fraction here of 2x minus 6 over 4x plus 5. So all I'll do is set f of x equal to 0. So 0 will equal 2x minus 6 over 4x plus 5. Now to solve this, I'm going to multiply both sides by 4x plus 5. Now what is 0 times 4x plus 5? Well, 0 times anything is just 0. My right sides will divide out. My left side stays 0. So I'll get 0 equals 2x minus 6. I can add 6 to both sides, so 6 will equal 2x, and then divide by 2, and I find that x equals 3. Now all I need to do to check for an extraneous solution is check that this denominator, when I plug in x equals 3, does not equal 0. So I'll have 4 times 3 plus 5, that's 12 plus 5 is 17. The important thing, it's not 0, so we can be pretty confident in our answer of x equals 3. All right. Let's try this one. Letter C. J of x is 4 times the square root of 3x minus 8 plus 2. So here's another one that we'll definitely have to check for extraneous solutions on. Let's start. Set j equal to 0. So set j of x, excuse me. So we'll have 3x minus 8 and then plus 2. All right, to solve this, I'm going to start by subtracting 2. When I do that, I get negative 2 equals 4 times the square root 3x minus 8, and then divide by 4. Negative 2 over 4 becomes negative 1/2 equals the square root of 3x minus 8. Now, how do I undo a square root? I need to take and square both sides. All right, so when I square both sides, I will have 1/4. Negative 1/2 times negative 1/2 gives me 1/4. It's 3x minus 8. When I add 8, think of 8 over 4, so that's the same as 32 over 4. So I'm adding that to the 1, so I'll have 33 over 4 equals 3x. I can divide by 3, or think of this as multiplying by 1/3, since we have this fraction. Multiply across, so I'll have 33 over 12 equals x. Now before I check that answer, or before I box that answer and make sure that's correct, I need to check it. So this answer is going to be extraneous, and let me show you why. So if I plug in 33 over 12, 33 over 12 is a little less than 3 or so, or sorry, yeah, just a little less than 3. So I'm going to get 4 times the square root of about 1 plus 2 equals 0. So when I simplify this, I'm going to have a number around 1. 4 times 1 is 4 plus 2. I'd get 0 equals 6, which is not accurate, is it? That is not correct. So we will say that this is extraneous. And let me show you how I knew this was going to be extraneous. It was in this step right here. The negative 1/2 equals the square root of 3x minus 8. Let's rewrite that down here. Negative 1/2 equals the square root of 3x minus 8. I knew at this moment we were going to have an extraneous answer. How did I know that? Because I had a negative number equal to a radical. And we know that square roots, it's impossible to get a square root that is negative. They will always be positive. All right, so anytime you see negative equal to just the radical, we know that that's going to be extraneous. All right, let's move on here. Let's look at letter D. So for letter D, I'm going to set g of x equal to 0, 2x squared minus 5x minus 3. Now this is a quadratic equation. We haven't really dove into how to solve these yet, but hopefully we have a couple ideas from our prior classes. We can do factoring, we can do quadratic formula, whatever works here. Let's see if this is factorable. I think it is. So we'd have 2x and x, we would need it to become negative 3, positive 1 there. So 2x times x would give me 2x squared. 1 times negative 3 would give me negative 3. 2 times negative 3 would negative 6. Positive 1, so that would give me that negative 5 there. So I can be sure that these factors are right. Set each of them equal to 0. So 2x plus 1 equals 0. X minus 3 equals 0. Now I'll find that x equals negative 1/2, or x equals 3. And there we go. All right, no need to check those. That domain, negative infinity to infinity for a quadratic function, so we're good there. All right, letter F. X squared minus 7x plus 10 over x minus 5. We'll set this equal to 0. Over x minus 5, we're going to multiply both sides by x minus 5. When I multiply x minus 5 times 0, I'm left with just 0. But on the right side, those will divide out. So I'll have 0 equals x squared minus 7x plus 10. I can solve this by factoring. This one's a little easier than our last one. X minus 5, x minus 2. Set both of those equal to 0. I find that x equals 5 and x equals 2. However, we have a fraction here. We have a rational expression. So I need to check. If I plug in 2 to my denominator, I get 2 minus 5, I get negative 3. That's great. But what happens when I plug in 5? I get 5 minus 5, right? 5 minus 5 is 0. I cannot have a denominator of 0, which means that x equals 5 is extraneous. There is only one solution to this one. It is not x equals 5. It is x equals 2. All right, last one. Looking at letter F here, h of x equals 1/2 the square root of x minus 6 minus 3. So let's start by setting this equal to 0. 1/2 the square root of x minus 6 and then minus 3. So I'm going to add 3. So 3 equals 1/2 times the square root of x minus 6. Multiply by 2 on both sides to get rid of that 1/2. So I'll have 6 equals the square root of x minus 6. So notice over here, when I have that square root all by itself, it's equal to a positive number. That's good news for us. We like that. All right, so now I can square both sides, and I'll get 36 equals x minus 6, because that square undoes the square root. Add 6 to both sides, 42 equals x. Jackie Robinson, all right? So x equals 42. When I do that, do I get a true statement when I plug it back in? 42 minus 6 minus 3. Remember, we got to check these, got to make sure that we are getting a real answer and that this isn't extraneous. 42 minus 6 is 36. So 1/2 the square root of 36 minus 3. The square root of 36 is 6. Half of 6 is 3. 3 minus 3 does in fact equal 0, it checks out. We can be very confident that x equals 42, aka the meaning of life. Shout out to you sci-fi fans out there. All right, well, this is solving for zeros. Hopefully we're feeling good. If you want a little more practice or a few more examples, go ahead and check the samples video. Otherwise, dive into those practice problems and hopefully we can crush them. So this is Mr. Carter signing off. I'll see you next time.